Good morning and welcome to the Maths Paper 3 Reasoning during your SATS week. So if we look at the first page, you will notice on here that you had 40 minutes. I wasn't really bothered how long you took. Hopefully nobody took much longer than 40 minutes. But I'm not really worried about how long you took because it's not a real test. Oops, sorry. So let's look at the first question. It says, here is a diagram for sorting numbers. Write one number in each box. I might write more just as an example, but you should write one in each box. And let's see how the box works. So in this box here, you should have a multiple of 5 and a multiple of 3. So 30 is 10 times 3. And is 6 times 5. So it's a multiple of both 5 and 3. Okay, so if you've not had to go at this one yet, do that now. Okay, so in this box here, we want a number that is not a multiple of 3, but is a multiple of 5. It's where these two meet. So it's not a multiple of 3, but it is a multiple of 5. So let's write down the multiples of 5. I don't think we need to go much further, but we can just use it as a revision tool. Let's see now which ones are also multiples of, that are not multiples of 3. So you could have had 5, 10, 20, 25 and 35. Any of those numbers could go in there. I'm going to choose to write in 5. You can't have 15 because it is a multiple of 3 and 5, and you can't have 30 for the same reason. It's a multiple of 3 and 5. You could have had any of the others, and it goes on, obviously, 40, 45, 50. You can't have 45 because that's a multiple of 3 and 5. Okay, if we look at this one, not a multiple of 5, but it is a multiple of 3. So let's write down those numbers where it's a multiple of 3 but not a multiple of 5. So we write down 3 times, oops, what have I done that? Oh, sorry, me being silly. 3, 6, 9, 12, 15, 18, 21. I don't need to go any further. As you can see from that, let's go back to blue, I think. We could have had in here, it's got to be a multiple of 3 but not a multiple of 5. So you could have had 3, 6, 9, 12, 18, 21. You could have had 24, 27, 33. You can't have 15 because that is a multiple of 5 as well as it being a multiple of 3. So any of those, I'm going to choose the first one, 3. And then in this one here, you needed ones that were not a multiple of 5 and not a multiple of 3. So if you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of those ones, the ones you could have had are, you could have had 1, you could have had 2, you couldn't have had 3, you could have had 4, you couldn't have had 5, you couldn't have had 6, you could have 7, 8, you couldn't have had 9, you could have had 10. So I'm going to go for 1 in there. Okay. Move on. Here is a number line. Write down the missing numbers in the box. So this is the negative numbers that we've been doing recently, so hopefully you did have a go at these. We want a number which is minus 5, add 7. Now, whenever you're doing, if you're not very confident on negative numbers, I would consider a number line. So you'd have minus 5, minus 4, minus 3, minus 2, minus 1. Minuses aren't coming out very well. 1, 2, 3, etc. And then we're starting at minus 5 and we want to count on 7. 1, 2, 3, 4, 5. So it takes us 5 numbers to get back to 0 and then another 2 up to 7. Okay, and then we've got the opposite problem where we've got, it starts at minus 5 and you want to count back . Okay, and you want to count back 7. So go 1, 2, 3, 4, 5, 6, 7. And the answer showing there is minus 12. Okay, perfect. Very well. So this one, nice and easy. We did this right at the beginning of the year. Look at this number. Read it out loud yourself. It says 23,451.96. And we want the digit, that just means the number, that is in the hundreds place. And we want hundreds, okay? So I think we already know that that is units, tens, hundreds, thousands, and then tens of thousands. So we want the number that's in the hundreds place, so we should be looking at 451. So you're just writing the digit, you don't need to write the 400, you can just write the 4. Okay? You don't actually get the mark if it's 400, although it does show me that you understand it, so I'm not too worried, but in the SATs you wouldn't have got that mark. It should just be the 4 because it says write the digit. Okay? The next one, let's get rid of all of this because it's quite messy. Let's look at the next one. It says write the digit that's in the hundredths place. So hundredths, you can see they're not the same word, hundred and hundredths. So if you can think back to the place value charts that are in all your rooms, that one there is tenths. This one there is hundredths. I don't know, I've written that one in words and that one in numbers, but anyway, the hundredths place. So the number that's in the digit that's in the hundredths place is a 6. And again, that's what you should have written. If you've written 0.06, you wouldn't have got the mark in the SATs, although I do understand that you know what it is, so I'm not too worried. Okay, next one. Number 4 already, we're on number 4. A school plans to collect £200 between January and May. This chart shows how much they'd collected by the end of April. So on all of these, I always think that we need to take a little time to get to understand the chart that we're being shown. Let's have a look. Here we've got these ones are the months. So this is how much they earn in January. This is how much in February. And this one in March. And this one in April. Okay? And altogether, that's how much they've raised out of their target of £200. Okay, so let's have a look. Write the name of each month, so every single month, where they collected more than £50. So let's go back to our original. Sorry. I'm going to take these off because it's slightly confusing now that we understand what the chart's about. So in January, how much did they collect? Well, that's easy because they did 0 to 20, so they're £20 in January. In February, they went from 20 to what we're going to like 70 something, didn't we? So let's say that's 75, that could be £55. And in March, they went from 75 to 100. So that would be, oops, don't know how I got that. So that would be £25. And in April, they went from 100 to about 165. So that's £65. Okay, so each month where they collected more than £50, you should have had February and April. The one that was there that was a little bit tricky was this February one. So if we look at the February one, you can see that it definitely starts at 20 and halfway between 60 and 80 is about there, isn't it? So you can see that it's over 70. So hopefully you got February for that one. Okay. How much did they collect in February and March all together? So just those months, but all together. Okay, let's have a look. We've got February and March, so we can get rid of this really because we don't need that anymore. We can look at February, which started at £20. can look at March, which finished at £100. So the amount that they raised in this section, just February and March, is £80. It's 100. Oops, sorry. It's 100. Take away 20, which gives you £80. Okay. You have to add them together, both February and March total, to understand how much. Okay, so Chen, SATS test Chen is back. Chen appears in most of the SATS tests. She'll be having a holiday sunning herself in some park or other, probably, because she's not got the SATS to look after. So, pours 165 millilitres of milk into a measuring jug. And it says draw an arrow on the jug to show the level of the milk. So we can see it's going up to 20, 40, 60. So we know that the one in between is where the tens are, isn't it? Because it's halfway. Oh, 60, 70, 90, 100, 120, 130, 150, 170, 190. So that's what those notches are. They're the tens in between these numbers here. Okay, and we wanted the number that's halfway between 160 and 170, because don't forget we wanted 165. So that should be about, it's hard for me to be precise on this screen, but somewhere, as long as you've got it halfway between those two, then you'll be okay. That's not brilliant halfway, but somewhere around that's about right. Okay, somewhere around there. Okay, next one. Here are 6 cards. Have a look at them all. They're all multiplying, dividing by 10, 100, etc. And it says here, use a card to complete each calculation. So you need to use one of these cards to put in here. Okay, so we've got 5.3 and we want to get to 0.53. So if we look at the decimal point, we're going to move it one space, aren't we? We're making it 10 times smaller, one lot of 10 smaller. So the card that we need in there is divided by 10. If you're making the number smaller, you're dividing, we're making it 10 times smaller, one decimal place smaller, so it's dividing by 10. Okay, this next one, we're making it a bigger number. We're going from 5.3 to 5,300. So, how many decimal places are we moving that? So it's 5.3. Let's put some zeros on the end so we know what we're doing. We need 2 zeros, don't we? I'll put 3 just to be on the safe side. How many decimal places have we increased by? Well, 1, 2, 3 decimal places, haven't we? So it's got 1,000 times bigger. The number 5 to 5,300, 5.3 to 5,300 is 1,000 times bigger, and it's getting bigger, so we know it's multiplying. So it should be this one, shouldn't it? Write that in. Oops, sorry. Oh, all over the place. Times by 1,000. So hopefully you got that. And then finally, we're going smaller again, aren't we? We're going from 5.3 to 0.053. So 5.3, and I'm going to put a few zeros in front. So I can count how many decimal places we've gone smaller. So I've gone 1, 2 places smaller, haven't I? So my new decimal point is there. I've gone 2 places smaller. I've made it 100 times smaller. This number, 2 decimal places, so that's 100 times smaller. So you should have had this one divided by 100. You know that's 2 decimal places smaller because it's got the 2 zeros on the end. And the zeros relate to the decimal place. Okay, number 7. Write the number, whatever that is, in words. Well, that number, as we know, is 53,148, which should look like 1,148. I'm not too worried about the hyphens, the capital letter or the comma, as long as you understood what the number was. I'm not that bothered about spelling, but it would be nice if you'd spelt it correctly. Right, here is a shaded shape on a grid. Now this is what we were doing last week with translations, and it says translate the translate the shape so that point A moves to point B. Point A moves to point B, okay? And then draw the new shape in its position. So let's see how far point A has moved to point B. So if we count it 1, 2, 3, 4, 5 to the right, so let's write it up here so we don't forget, and 2 down. So that means each point on this shape needs to move the same. Okay, so let's get rid of those there. We're going to move this point now, this point here, we're going to move that 5 to the right and 2 down. So 1, 2, 3, 4, 5, 2 down, mix it there. I would normally put a cross, but it's a little bit tricky on this iPad. Okay, now I'm going to move this point here, 1, 2, 3, 4, 5 and 2 down. So that ends up there. I'm going to move this one, 1, 2, 3, 4, 5 and 2, oops, need a little bit more space, 2 down, we'll put it there. And get rid of those because that's in the middle of the shape. And then you need to join it up using a ruler preferably, although I do accept you might not have one at home, but hopefully it's not very precise on the iPad, but anyway, it should look like that, something like that, but with straighter lines hopefully. Now if you didn't get all of that right, you get 1 mark for 2 vertices correct. If you didn't even get 2 vertices correct, you don't get any. But if you get all of them right, you get 2 marks. And the vertices obviously are the corners, not the B because that was already there. But if you get 2 of these correct and 1 wrong, then you get 1 mark. If you get them all right, you get 2 marks. And that was a nice easy one for 2 marks after what we did last week. Right, the mass. Now, commonly we call mass weight, but scientifically, as Mr. Miller tells our group all the time, mass means the gravitational pull of it. So the mass of a 10p coin is 6.5 grams. The mass of a 5p coin is half the mass of a 10p coin. Half the mass of a 10p coin. What is the mass of these 6 coins all together? Okay, so we know that 10p coin is 6.5 and a 5p coin is half of that. So the first thing I want to know is how much are the 5p coins. That would be my first action. So for 5p, in here I'd want to see 5p equals 6.5 divided by 2, and then work out your 6.5 divided by 2. 2's into 6 goes 3, decimal point. 2's into 5 goes 2, I've got 1 left over and I'm going to add a 0, aren't I? And 2's into 10 goes 5. So a 5p coin is 3.25 and I've got 3 of those. 1, 2, 3. So the next thing I'm going to do is I'm going to work out my 5p. So I need to do 3.25 times 5, because that's the mass of the 3.2 of the 5p coins is 3.25 grams. So I'm going to work out, I've got 3 of them. I've done 5 down there, I'm an idiot. Let me just work that out. I've got 3 of them, so I'm going to work that out. 5 3s are 15, 2 3s are 6, add 1 is 7, hello decimal point, and then 3 times 3 is 9. So my 5p coins add up to 9.75 grams. And then I want to work out what the 10p coins add up to. How many 10p coins have I got? I've got 3 and they were 6.5 grams. So then I can do that next to it. So 6.5 times 3. 5 3s are 15. Below decimal point. 6 3s are 18. Add 1 is 19. So 19.5. But then I want them all together, so I need to add those together. 19.5 add 9.75. Obviously, to make it easy, I'm going to put that 0 in. We don't need to, but it helps. 7 add 5 is 12. Below decimal point. 9 add 9 is 18. Add 1 is 19. And 1 add 1 is 2. So the answer is 29.25 grams. If you're not sure, go over that again. The only tricky bit really was working this out. 3.25, that's the tricky bit. You could, of course, have just listed those. So you could have done, I know some of you prefer to do this because you don't trust your multiplication, so you could have done that and then just added them up. That's fine as well. Either way is fine. And then done the same with the 10p coins. Oops. And then added those together to get the answer. Okay, either way is fine. If you're not sure, just go over it again, rewind, just go over it again. Okay, moving on to number 10. We've got a bag of 5 lemons here, costs £1, and a bag of 4 oranges costs £1.80. And the question wants to know how much more does 1 orange cost than 1 lemon? So we already know that these are more expensive than those because it tells us in the question. So if we get it the wrong way around, we know we've done something wrong. So 5 lemons cost £1, so lemons. If you want to know what one of them is, it's going to be £1 divided by 5. So you would do your £1 divided by 5. 5s into 1 doesn't go. Carry your 1. And you get 20. Now if you leave it 2, that's not an amount of money, is it? It's not right, that is it? So you know that it's 20p. So for oranges, you've got 4 for £1.80. So you need to do £1.80 divided by 4. 4's into 1, carry 1, 4, 2 left over, so that's 5. So that makes 45p. Okay, so how much more expensive is it? You're going to do 45p, take away 20p, you're going to get 25p in there. What I'm getting from that is oranges are quite expensive. Oops, sorry. Next one. Write 4 missing digits to make this addition correct. So, you're going to start in the same place that you would always start with any addition, which is in this column here, isn't it? You'd always start with this column. So what can I add to 8 to get, and you want to get 9 at the bottom here? So you're going to put a 1 in there probably. That looks about right. And there's nothing to carry. We're not carrying anything. So it's just carrying on as normal. So you've got your 9 here. And you want the answer here to be a 1. Well, obviously it's not a 1 because you don't add something to 9 and get 1. So it must be 11. Okay, so what do you add to 9 to get 11? Well, that's 2, isn't it? So 2 add 9 is 11. Don't forget, this is where people go wrong, to carry your 1 up there from the 11. And then you've got 6, add something is going to give me a 0. So that must be 10, mustn't it? So you've got a 1 up here, so 6 add 1 is 7. So I'm thinking that this must be a 3. 6 add 1 add 3 gives me 10. Then I've got my 1 to carry, don't forget to carry your 1s. So 3 add 1 add something is going to give me 9. So 3 add 1 is 4, I think that must be a 5. Now I'm not going to leave it there because I'm not daft, I'm going to actually work it out. Now that I think I've got the right answers, I'm going to try and work it out. So I've got 8 add 1 is 9, 2 add 9 is 11, carry 1. 6 add 3 is 9, add 1 is 10. 5 add 3 is 8, add 1 is 9. Okay. If you went wrong, it was probably that you didn't carry these ones. Okay, so two decimal numbers add together and equal 1. One of the numbers is 0.07. So what do we add to 0.07 to get 1? Add something equals 1.000 if you like. Okay, so the easiest way to do that is to do 1.000 take away 0.007. It's a long borrow, but if you're in Mrs. O'Reilly's class, I know that she's already taught you to do this, so we need to do that, and then that, and then you get there. So 10 take away 7 is 3, 9 take away nothing is 9, 9 take away nothing again is 9, 0 take away 0 is 0. You get 0.993. Just move that out so it doesn't get in the way of the next question. Okay, here are 4 fraction cards. And we need to use 3 of the cards, just 3, to make this correct. Now there are a couple of different answers here. Well, there are lots of different answers. But the thing that you need to realise is that you can't really measure them at the moment. The easiest way to measure them is to make them all into equivalent fractions. So you need to find a number that they all go into. And I would choose, personally, probably 48. You might have chosen something different, but I would choose 48. So down here I'm going to work out what they all are. Out of 48, times by 12, times a 3 by 12, and I get 36. I'm going to highlight that so I know. And then I've got 5 eighths, and I want to make that out of 48, times by 6. 8 sixes are 48, so I times that one by 6, and I get 30. So I highlight that one. 6 out of 12 equals something out of 48. Well, times that by 4, times that by 4, and I get 24. And then 7/16 out of 48, that's times by 3, times that by 3, and I get 21. So I'm quite happy if you've done that. You should really write the originals in here, because you use any 3 of these cards to make it correct, but I don't really mind whether you have or not. So as long as you choose ones that are right, so this one needs to be smaller than this one, which needs to be smaller than this one. That's the way it's going to work. So you could have had, one of the options that you could have had is, if we start with the smallest, 21 over 48. If we're using the original, we would use 7 over 16. Is smaller than 6 over 12, which is this one. Is smaller than 5 eighths, which is this one. So that's a possibility. You could have had 7/16, 6 twelfths and 5 eighths. Alternatively, you could have had, let's look at these again. Sorry, I'm just going back so you can read them more easily. Got some rubbed out, so just put those back in. That should be 24. Okay, alternatively, you could have had, say, 6 twelfths is smaller than 5 eighths, is smaller than 3 quarters. That's a possibility. Another possibility was, I'm just looking at the answers, 6 twelfths, oh, sorry, 6 twelfths, and then 5 eighths. But did we just do that one? 6 twelfths, 5 eighths, 3 quarters. Oh, I know what we didn't do. Sorry. We didn't do 7/16, 5/8, 3/4. That. Or you could have had, I don't know if we did this one or not, 7/16, 6/12, 3/4. There are a few answers there that you could have had. As long as you got one that was right, it doesn't matter which one. I think we've done them all now. Okay. If you've got anything different from that, and I've not been over it, it's a bit tricky to keep track of the mark scheme here, but let me know and I'll let you know whether it's right. So here is a number pyramid is the next one. So the number in the box is the product, and that's our first problem, of the two numbers below it, because our first problem there is what is a product. So a product means the answer when two numbers are multiplied together. So if we say 5 times 2 is 10, the product of 5 and 2 is 10. That's the product. So in our problem that we've got here, we've got 2 times something is going to give us 5. So what do we times 2 by to give us 5? Well, the easy answer to that is to divide. So 2 into 5 goes 2, with the 1 left over. 2 into 10 goes 5. So that should be 2.5. And you can check it by doing 2.5 times 2 will give you 5. The next easiest one to do is this one, and we're going to do that in the same way. So 5 times something is going to give us 22.5. So if we're not sure straight away, we'd need to do this, wouldn't we? 22.5 divided by 5, because 5 times something equals 22.5. So to work out what this something is, we need to use 22.5 divided by 5. 5 into 2 doesn't go, 5 into 20 goes 4. Decimal point, put your 2 in. 5 into 25 goes 5, so that there should be 4.5. And again, you can check that by doing it the other way around. So 4.5 times 5, 5 5s are 25, decimal point, 4 5s are 20, add the 2, gives me 22.5. So I know that I'm right with those two. Okay, now I need this one here and this one here to give me 4.5. So this is 2 times something equals 4.5. And we need to work out what that goes in that something. So I'm going to do 4.5 divided by 2. 2 into 4 goes 2. 2 into 5 goes 2 with the 1 left over. 2.25. Oops, sorry. 2.25. Okay, now I'm going to check that one as well by doing 2.25 times 2. 2 5s are 10. 2 2s are 4, add 1 is 5. 2 2s are 4, so 4.5. Of course, 4.50 is the same as 4.5. So just to recap, this times this gives you this. 2 times 2.5 equals 5. That's how you work these two out. And it's the same for all the others. So 2.25 times 2 gives you 4.5. And then 4.5 times 5 gives you 22.5. Okay, number 15. It says join the dots on the grid to make a quadrilateral that has 3 acute angles. So a quadrilateral, we should know now that quad means 4. You needed a 4-sided shape that has 3 acute angles. What's an acute angle? An acute angle is less than 90. It's very cute. It's really tiny and cute. So an acute angle is like this or like this. So it's going to be, it could even be really tiny like that. So you need a shape using the dots with 3 acute angles that has 4 sides. So one of the possibilities is to go something like, so we use that one and that one, and say that one, and actually let's move that one across one, sorry, that one and that one, and then we can do that, do that, do that, do that. Oops, didn't quite join, but you get the idea. So, and then you check, obviously you'd have a protractor if you're in school, but if you haven't got a protractor and you need an angle that's less than 90, you can use the corner of a piece of paper, because the corner of a piece of paper is at a right angle, which is 90 degrees, so it will be less than your piece of paper, but all of those are acute, so that's one possibility. So we'll look at a different one. You could maybe have gone, let's say we use that one, and that one, and that one, and say that one. You could have gone up to there, and then down to there, and then down to there, and then up to there. That's an inverted kite, so you could have used that one. Or another possibility might be that you just did an irregular shape, so maybe there, to say there, to say there, to there. If we try and join those up, 1, 2, 3, oops, no, that's not going to. That's not going to work, is it? Because that one's not acute. Oh, it's got to have 3 acute angles, so we're right there, haven't we? 1, oops, haha. So it needed 3 acute angles, and you've got 1, that one's acute, that one's acute, and that one's acute. This one's obtuse. This one here is obtuse, but the other 3 are acute. You might have something different, that's fine, as long as your angles are less than 90 degrees, which is less than a right angle. So you need 3 angles which are less than 90 degrees. Okay, next one. Laura chooses number less than 100. She divides it by 3 and then subtracts 11. She then divides this result by 2 and her answer is 10.5, and we want to know what was the number she started with. Now, I have told you this before, but where you've got an answer and you need to find out what you started with, the way you do it is to work backwards and in reverse. So you start with 10.5 and then you do the opposite but going backwards. So you start here and then go to here. She divides this result by 10, so we're going to do the opposite of that. So we're going to do timesing. Oops. Timesing by 10. So we start with 10.5, sorry, by 2. 10.5 times 2. If you want to work it out over here, you can. You should get 21 equals 21. So that's my next thing. Then here it says she subtracts 11. But we're not going to subtract 11. We're going to do the opposite. So we're going to add 11. So 21 add 11 gives me 32. And then here it says she divides it by 3. Well, we're going to do the opposite to dividing by 3, and we're going to, oops, times by 3. So 32 times 3 gives me 96. And then we're at an end. And we have a number less than 100, so it seems to fit. We think it's 96. Obviously, the thing to do is to check your number, isn't it? So we'll do it the right way around this time. So she chooses a number less than 100. We've chosen 96. She divides it by 3 to get 32, and then takes away 11. So here she's going to have 21. And then she divides this result by 2. So 21 divided by 2 gives me 5. And we get 10.5. So we know now that the answer is 96. So that's a trick. Well, it's not a trick, it's the right way to do it. When you know what the answer is, so we knew what our answer is, you go backwards and in reverse. You switch everything around to get what the starting number was. Okay, so this model is made with 20 cubes. What percentage of the cubes in the model is black? So we need the percentage of these cubes. What percentage is black? Okay, so let's count how many are black. 1. And I'll use different colour that might be able to see. Grey. 1, 2, 3, 4, 5, 6, 7. Obviously that's just the other side of the same cube. So we've got 7 cubes which are black. And then we need to see how many we've got that are white. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've got 13 white. So if this were a fraction, we'd want to know what fraction of cubes were black out of the whole thing. So out of the whole thing, we've got 7 that are black out of 20. Because we've got 20 cubes altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 17, 18, 19, 20. Okay, so we've got 20 cubes altogether. So 7 out of 20 of them, if that were a fraction, that would be easy, we could leave it there, but they don't, they want a percentage. Now, we know something about percentages, and we know, I hope, that all percentages are measured out of 100. So if we've got 7 out of 20, we actually want a fraction that is out of 100. We just need the equivalent fraction. So we've got 20 out of 100, and we know that's times by 5. 20 to 100 is times by 5. So we know how to do equivalent fractions, I hope. So we do 7 times 5. Because we times the 20 by 5, we do the same to the denominator and the numerator. So we should get 35 out of 100. So the fraction, the equivalent fraction of 7 out of 20, because 7 are black out of 20 altogether, is 35 out of 100. And then that gives us the percentage, because it's 35 out of 100, 35%. So for every 100, we have 35% of them. 35 of them would be black. Okay, lovely. Right, we have done this one in class. Well, my group have. I don't know about other groups, but I know that we've done this. So here are the ingredients for chocolate ice cream, making me hungry. There's our chocolate ice cream. So we need cream, milk, egg yolks, chocolate and sugar. Stefan has only 300 millilitres of cream to make chocolate ice cream. How much chocolate should he use? So he should have 400 ml and he's got 300. Now it's not so easy as to say that he uses 100 less, is it? Because what he's actually got is 300 out of the 400 that he should have. And that, as an equivalent fraction, is 3/4. So he's got 3, this would all be in this box obviously, but I want to show you the chart, so I don't want to move the box up and down. So he's got 3/4 of the ingredients. So he should only use 3/4 of the chocolate. So we need to know, he should have 120 grams of chocolate, but if he's going to make it properly, he should only use 3/4 of it. So we need to know what 3/4 of 120 is. 3/4 of 120. We know, I hope, that means find 3/4 times 120 over 1, which gives you 360 divided by 4, which gives us 90 grams. Alternatively, instead of doing that, you could have found 1/4. And to find 1/4, you do 120 divided by 4, which gives you 30. And then 3/4 is 1/4 times 3, so 30 times 3, which gives you 90 as well. Okay. Lovely. And now I know that we've definitely, I think, all done this one probably, but you can have another go at it. Hopefully you did have another go. I always find pictures quite useful. So the area of a rugby pitch is 6,108 square metres. So area, here's my rugby pitch. Okay, and it is 6,108 square metres, 6108 metres squared, 6,108 square metres. And then a football pitch measures 112 metres long and 82 metres wide. So if I drew my football pitch now, we'd say 112 by, what was it? 82. Oops, I've done that the wrong way around, haven't I? Doesn't really matter, but that should have been 82 and 112. So let's go back to the question. What's the question asking me to do? How much larger is the area of the football pitch than the area of the rugby pitch? I already know the area of the rugby pitch. I need to work out the area of the football pitch. So for that, I'm going to need to multiply those two together. So 82 times 112. I'd start with 112 on top. 82. 2 is 1, 1 to 2 is 2, 1 times 2 is 2. Put my 0 down for my tens. 2 8s is 16. Once 8 is 8, add 1 is 9, and once 8 is 8. Add those together. 11, 9184. Okay, but that's not the end of it, because what I actually want to know is how much larger is the area of the football pitch than the area of the rugby pitch. So I need to do 9184, take away 6108, and 4 take away 8, can't do. So 14 take away 8 is 6, 7 take away 0 is 7, 1 take away 1 is 0, 9 take away 6 is 3. So the answer is 3076. So it's a 3-mark question. Now you can judge for yourself how many marks you think you've got. If you've made one error, just one arithmetic error, so if you got something different here, for instance, but then you put whatever you got here, so say you put 918, say you got, I don't know, there's 7 there, for example, and then you put 7 there, that's fine, you get 2 marks. If you got 2 errors, so you then did this one wrong as well, so you did 7 add 8 is, I don't know, 15, then you get 1 mark. So you'll have to judge. It's hard for me to judge if I haven't seen it, but basically, obviously that shouldn't be right, that should be 4, and that should be a 4 as well. So basically, if you got all of it right, 3 marks, big 3-mark question. If you got one of them right, if you got 1 mistake, 2 marks. If you got more than 1 mistake, 1 mark. Okay, coordinates. I know we've loved doing coordinates at home. So, always tricky to do coordinates teaching remotely. But let's have a look at this one. Here are 2. Now, you've got some keywords here. Identical shaded triangles on coordinate axes. We know they're identical. They're exactly the same. Let's see what the question says. Write the coordinates of point A and point B. Now you're going to think, how on earth am I going to work that out? Well, let's have a look. We've got this one is 0.8. So we know that that's on the 0 on the x-axis, and that's 3 on the x-axis. So we know that the width of that triangle is from 0 to 3. It's from this 0 to this 3. That's the width of the triangle. So if we're trying to work out what this one is here, that's 9. We know that the width is 3 because they are identical. So that's going to be 12, and it's going to be 12 something. And if we look at this one, we can see that that's 8 and that's 8. It's a straight line. So we know that on the y-axis, that number there on the y-axis should be 8. And these are identical too. So where that's 8 and that's 8, this is 0, so that's 0. Because it's on the 0 line on the y-axis. Okay? I know this is tricky, so don't lose heart if you've not got this one right. Don't worry about it. This is one of the trickier ones on the paper. Particularly because we've kind of taught all this from a distance. So we know on the y-axis here, that was 8, so that's 0. So the point A should be 12, 0. Now let's look at this. What is this point here? It's 0, 0, isn't it? Should have written that in the beginning really. It's 0, 0. So we know for this one here, 0, 0, 9. That's in a line there. We know that's 0.9. So this one is also 0.9 on the x-axis. So it's in a line down, isn't it? It's the same distance across from 0. And then we want, how far down is it? We want this measurement here, don't we? Just get rid of that so you can see. We want this measurement here. So we need to know how long is the triangle. Well, this triangle goes from 0 to 8. It goes from 0 here up to 8. So it's 8 long. So this one's going to be 8 long as well. And it starts on 0, but it goes downwards. It's not going up, it's going down. So we should know that that's -8. So this one should be -8. Now that is a tricky one, do not worry, there's some things that are very difficult to teach from a distance, and this is one of them, but that's 9 minus 8. For those of you who got it, well done. If you're not sure, just go over it again. It's all about using the measurements of the existing triangle that we did know. We knew that what the measurements were for this one, so we could have used the measurements that we knew for this one, this new triangle. Okay. Oh, it's at the end. Ah, it's the end. Enjoyed that. So happy Sats week. Have a lovely day. I hope you enjoy yourself, and I will speak to you again tomorrow. Bye.